All right, this graph, we're going to kind of put everything together with polynomials. The last video, we found the end behavior. Now we're going to find the middle part of the graph by finding the zeros of the equation or zeros of the function. So the zeros, these are basically just the x-intercepts of the graph. And this is a mistake right here. This should say this is where y equals 0, not x, right? Because when you graph points on the y-axis, or excuse me, when you graph points on the x-axis, the y value is 0. So this should say, I'll rewrite it again, this is where y equals 0. All right, so that'll give us the middle part of the graph. And we'll also look at the behavior when the graph, as it moves left to right, how it hits that x-intercept. Sometimes it goes straight through the x-axis, sometimes it bounces off of it. All right, so if I were to do, I'm gonna zoom in here, if I were to do 2, or number 1, excuse me, we're going to get the rough sketch of this. Now, first, if I want to get the m behavior, I see that the degree is 3 and it's positive x cubed. So this is going to be like an S curve. The m behavior, it's going to go down to the left, up to the right. Now, to figure out that whole middle portion, we're going to find the zeros of this equation. So we're going to set y equal to 0. So we're going to have 0 equals x cubed minus x squared minus 6x. Now, what you're going to do really for most of these in order to solve for this is you're going to factor. So you're always going to look for your GCF first. For this one, it has a greatest common factor of x. So I can pull an x out. And if I pull the x out, I'm going to get a quadratic on the inside. I'm going to get x squared minus x minus 6. And then I could factor this quadratic. If this quadratic wouldn't factor, I would use quadratic formula. But this does factor to x minus 3, x plus 2. And if you set each of these factors equal to 0, you would see you're going to get 3 x-intercepts, or 3 zeros for it. Okay, it's going to be 0, 3, and negative 2. All right, so this is going to give us the middle part of the graph. All right, now if I just do this rough sketch right here, the first thing I'm going to do is I'm going to graph these 3 zeros. So that's just going to be 0, 0. Then this is at 3, 0. So 1, 2, 3. I have that point. And then negative 2, 0. All right. Now I said the end behavior was this, right? It goes down to the left, up to the right. And you're going to see it's going to match up. I'm going to put an arrow to the left, right? This is just a rough sketch. An arrow to the right. Now what's going to happen is we're going to go left to right, and it's going to go through the x-axis at all 3 of these intercepts. The reason why is all of these are raised to an odd power. As soon as these factors are raised to an even power, that's where it's going to bounce off the x-axis. And we're going to see that happen on a later one. So when we graph it, it's going to go straight through, straight through, straight through. And see how it matches up with the end behavior. Now, when we look at this, like I'm not sure like how far it goes up. I wonder if this has a laser pointer anywhere in here. I don't think it does. Oh, is this actually? Yeah, it has a mouse pointer. I don't know if you can see this right here. Hopefully you can see this. But now as far as how far this comes up, I'm not testing you. This might go up further, or it might only go up to like here. This is just a rough sketch. I know it goes above, it's got to come back below, and then come back above to match up with the end behavior. All right. Okay, let's move to number 2. All right. All right. So if I were to do number 2 right now, okay, I can first figure out the end behavior is actually going to be the same as the last one, right? It's just like the S curve. So to the left, it goes down, to the right, it goes up. And if I want to find the zeros, I set y equal to 0. Just like the last one, I can pull out an x. But on the inside, we'll get x squared plus 1. Now, if I try to solve for these, I would set this x equal to 0. So it's going to go through the origin. And if I set this equal to 0, I would get x squared equals -1. And I would just get plus or minus I, right? I would get plus or minus square root of -1, which is I. I can't graph that. So this is the only 0 we get. All right. So this is a really quick one. So I'm going to put that 0 in here, which is right here at the origin. And then I just put in the end behavior. And then it's just going to kind of look like the S curve. It'll just kind of come up like this and then go up. Now, if you actually graph this with T-inspired, it probably doesn't look exactly like it. But again, we're just coming up with the rough sketch. All right. Okay, let's move. I'm going to move all the way down to number 5. Okay, this is going to be one where we're going to see a bounce off an x-intercept. And probably these other ones we'll do in class. All right. So if we do number 5, we can see that the degree is even, and it's positive x to the 4th. So this is going to be like the parabola where they both go up left to right. Now to find the middle part, the zeros, we set y equal to 0. So we have 0 equals x to the 4th plus 4x cubed plus 4x squared. And this is going to have a GCF of an x squared. So I can pull an x squared out. And then on the inside, we're going to get x squared plus 4x, and then just plus 4. So we're left with a quadratic on the inside. Now this x squared plus 4x plus 4, that's a perfect square. This would factor to x plus 2 quantity squared. Now these are called, we're going to get 2 double roots. And let me put this right here. If you get a double root, when we graph, it's going to bounce off the x-axis. So we'll say a double root bounces off the x-axis. All right, so these 2 double roots, if I set the x squared equal to 0, well, that's just 0, so it hits the origin again. If we set x plus 2 equal to 0, we get -2. And since these are both double roots, because they're raised to this 2, they're going to bounce off the x-axis. All right, so that's how the behavior changes when it hits the x-axis. And actually, it would do the same thing if this was raised to an even power. So if these exponents out here were like a 4, 6, or 8, same thing's going to happen. It's going to bounce off the x-axis. But if this was, let's say, raised to the 3rd power, it would go straight through the x-axis. All right. To get the graph, okay, let's graph our x-intercepts, which is the origin, and then at -2. And then the end behavior was this, that both goes up. So to the left of that x equals -2, I'm just going to draw an arrow that goes up. To the right of the origin, we'll draw an arrow that goes up. Now it's going to bounce. So when it hits here, it bounces off it, and then it's going to come back down, bounce off of this, and see how it matches up with the end behavior. Now, again, we do this. I'm not sure like how far this goes up right here, but it's just a rough sketch. All right, so this kind of puts everything together. We can get a rough sketch of a polynomial by first finding the end behavior, then finding the zeros, and then if the zeros, if it's a double root or it's raised to an even power, it's going to bounce off the x-axis.